Let's take a step back from the web page, from working with the DOM, into more JavaScript theory or into important data structures you have in JavaScript. To be precise, let's have a closer look at arrays and iterables in this module. Now, of course, we already worked with arrays, but always in a very basic way. Turns out there are many interesting things you can do with arrays, many things you can know, and therefore that's exactly what we'll have a look at in this module. In detail, we'll have a look at different ways of creating arrays. We'll have a look at how to work with arrays, how to manipulate them, how to add or remove items, what's special about them and how they behave. We'll have a look at a lot of important array methods which exist on arrays in JavaScript that help us transform array data, summarize array data, sort arrays, and all kinds of stuff. And we'll also have a look at other important iterables which you find in JavaScript, namely maps and sets. And I will also clarify what iterable actually mean. Well, let's start with that right away. So what's an iterable in JavaScript? An iterable can be defined technically. There, it's basically an object or any objects that implement the iterable protocol and have this add iterator method with the symbol iterator property. Now, symbols are a special type of values in JavaScript. We'll dive into them way later since they're really niche and specific. And therefore, the human readable definition of an iterable in the end is that we can use a for off loop on it. Yes, it's indeed as simple as that. We can loop through it with for off. Now, the important thing is that not every iterable in JavaScript is an array. We worked with arrays thus far, but there also are other iterable objects like a node list, for example, which we saw in the last course module, but also strings and also maps and sets, at which we'll have a look at later. Now, there also is another term which I already used, and that's array-like. And that's actually not the same as an iterable. Both iterable and array-like are official terms in the JavaScript language. Now, what are array-like objects, therefore? Again, the technical definition is here much more readable, that an array-like object are in the end any objects that have a length property and use indexes to access items. It's as simple as that, and I'd say that's also pretty clear to us humans. Now, just as with iterables, not every array-like object is an array. That's why it's called array-like. We have array-like objects like node list and string. Node lists and strings are objects that have a length, that have indexes, and where we can use for off, and still they're not real arrays. Because, as you will learn in this module, real arrays have a couple of interesting behaviors and also a bunch of important methods available to them which do not exist on these array-like or iterable objects. Now, with these definitions out of the ways, let's dive a bit deeper into arrays before we then also have a look at other array-like objects and iterables. What if you want to create an array? Simple, right? You use the square brackets. Well, did you know that there are a couple of different ways of creating an array? Now, these are not all totally different methods, as you see, but actually how these methods create arrays also sometimes depends on the kind of data you pass to that method. So let's have a look at the different ways of creating arrays before we then work with them. And for that, of course, we'll not just have a look at that, we'll also see how that behaves and when you might want to use which. For that, again, attached you find a simple starting project, an empty HTML file which only imports a script, which then also is empty. And in there, of course, we can create an array of numbers, for example, with the square bracket notation. And I will say right away, this is the most common way of creating an array. It's the recommended way. Nothing wrong with that at all. So definitely use that to create an array. Only in very rare cases you want to create an array in a different way. Now here also, of course, as you saw throughout the course, you separate values by a comma. You can also have a trailing comma at the end. This won't hurt. You can have that for readability if you want it. Here my auto formatting removed it. And with that, of course, unsurprisingly, if I log my numbers here, and I then load this page and reload it, here is what I get in the log. Now that's not too new, that's what we knew. By the way, regarding how to read that, this is the array and this here is the length of the array. That's what's displayed there. You also see it if you expand it. Here you also have the length. Now, as I said, this is one way of creating arrays. As you saw on the slide, there are other methods. For example, let's create more numbers here. And another way of creating an array is by using a special keyword, the new keyword, and then array. Now this uses a so-called constructor function, something we'll also build on our own soon. For now, let's just take this for granted. And new array builds, well, a new array. Now if we console log more numbers here like that, and please note that I didn't pass anything to this array constructor thing. So if we log it like this and we reload this page, we see an empty array was created here, therefore with a length of 0. So new array like this is equal to this. Now if we change that and we pass in, let's say, hi and welcome, so 2 elements separated by a comma, and you can pass in as many parameters in the end because you're basically calling a function here. So you can pass in as many parameters as you want. Then you will see, if you now save this and you reload, well, of course, we got an array with these items here and a length of 2 therefore. Now it gets strange if we change that here and we pass in numbers. If we pass in 2 numbers, everything is good. If I pass in 1 and 5 and then we reload, we see an array with 1 and 5 and a length of 2. Now the strange behavior starts if I pass in just 5, let's say. Doesn't matter which number it is. If you do that, then we get this. We got an array with length 5, which actually is empty. We haven't seen that before. This is essentially an empty array with a fixed size, with a fixed length. Now, you will rarely need that, to be honest, but this is a strange way of creating an array, which, as I said, you won't need that often, but you should be aware of the fact that if you use, for whatever reason, this new array way of creating an array, if you pass a single number, this will be interpreted as the length of that to be created array, and an empty array of that length will be created instead of an array with that single number as a single value. Now that's just some specialty which you should be aware of. Now as I mentioned, in the vast majority of cases, you will create arrays with the square bracket notation. That's also better from a performance perspective, by the way. But if you ever encounter code where you see something like this, in some code you haven't written, or in code written by you, where for some reason you create an array with the new keyword, then be aware of this special behavior. Now another way of creating an array, by the way, is by omitting the new keyword, and that will behave in exactly the same way as if you add it. So here we get an empty array. As soon as we add more than one number, or any other kind of value, even if it's then just one element, we get an array with these elements. So new or not, you can add it or you can omit it. This in the end, calling array as a function, will give you an array like that, but again, typically you should use the squared brackets instead of that. Now another way of creating an array, yet more numbers, is with array.auth. This is a special method on this globally available array object, and there again you can pass in values, pass in 2 arguments here, for example, 2 numbers. And if we now console log yet more numbers here, you will see that this generates an array with these numbers. Now again, you should use square brackets. This will be slower from a performance perspective than that. You might wonder why it exists then. Same for that. There are rare niche cases where you might need such functions because you need to dynamically create an array of a specific length. But in the end, for now, I just want you to be aware of these methods because you might encounter them in other code snippets. You will not really have any use cases where you would need to create an array with these methods. So let's just comment this out, but be aware of them. Now, more helpful is a different way of creating an array. And that is, now I can use more numbers again because I commented this out, and that is array.from. Array.from is special. It does not take multiple numbers like this. If I would try to do that, if I would try to console log this here with multiple arguments passed in, you see I get an error because I must not pass in multiple arguments here. Instead, this takes an iterable or an array-like object, and that's the interesting thing. Array from in the end allows you to convert an iterable or an array-like object, which isn't an array yet, to an array. Now, of course, you can pass in an array here, but that doesn't make too much sense because that is an array already. So if you do that and you reload, It works, but you don't gain much. It's more interesting if you have an array-like object or an iterable which you want to convert to an array. Let's say here, a string, hi. If we pass this into array from and we reload, you see now we get an array where this is split into separate characters that make up that array. That can be useful if you have some string which you want to split into its individual characters. Array from makes it really easy and gives you a real array with which you can work. And you will see later in this module what you can do with a real array. It's a lot. This method is also useful if you have, let's say, a couple of elements in the DOM which you want to select as a node list or as a HTML collection, as you learned in the last lecture. And then you want to do something with these nodes which you can only do with a real array. So here, for example, I can have my list items, and I can get them with document query selector all li. This will select me all list items. But as you learned, this gives you a so-called node list. If I console log list items here, and I reload, you see I get a node list. This is an array-like object because it has indexes and a length. It's also an iterable because we can use for off on that, but it's not a real array. All of these array-specific methods you'll learn throughout this module will not exist on that node list. Now, if you would want to use one of these methods I'm about to show you later, well then you just have to take the list items here and pass them to array from. And now we have array list items, if you want to call it like this. And if you do that and you save that, now you'll see if I reload here, we got the node list, and then here we got the same elements, but now here in our real array. And the difference will be that you can now do anything with that real array, well, that you can do with real arrays. Use all these useful methods you'll learn about throughout this module. So that's how you can create arrays. The short summary is that you typically want to use the square bracket notation, and that array from can be useful for converting array-like or iterable objects to real arrays. Now that we know how we can create arrays, I also want to emphasize what you can store in arrays. You can store numbers, as you see. You can store strings, you can store objects. These are all things we did throughout the course. It's really important to understand that arrays can be of the same type, like hobbies, where we have cooking and sports, which are both strings, but can also be of mixed types, like personal data, where we might have the age as the first element, then the name as a second argument, and then even an object with more details, which might even be another array as a third element. So you can have arrays which are uniform or which have different types of data in there. You can also have nested arrays or multidimensional arrays, as they're also called. For example, you could have some analytics data, which is in the end an array of arrays where you have 1, 1.6, and then another array, minus 5.3 or 5.4, 2.1, and so on. So where you have an array where each element in the array is another array. And of course you could, for example, also loop over such an array, const data of analytics data. This will go over the outer array. So now data will be the elements of the array, so the nested arrays. So you can have a loop in a loop and go through the data points here, for example, of data. So data is this data, which is just one of the elements, which in turn is an array. And then console log data point here. That should be data point because we'll always have a look at one element at a time. So that's also something you can have. If I reload here, we see the data points being logged here. So multidimensional arrays are also a thing. And of course, you could have even more dimensions. You could have an array in an array in an array. You can also have a mixture of an array with arrays and then still have another element which is an object or a string. So you can also have mixed data in multidimensional arrays. So what I want to say here is you're really flexible there. Of course, if you would have an array with nested data and then you have some other element which is just a number, let's say, so not an iterable object, well then code like this would break because there we loop over this array with this outer loop, and we have a look at each array element, and then we loop over that array element again, which works for iterables, but not for numbers. So you have to be careful how you then use your array, but in general, you can store whatever you want in there. Nested arrays, nested arrays and nested arrays, mixed data, strings, numbers, whatever you need. Arrays are really flexible regarding the values you store in there. Also important to know about arrays, and something we of course had a look at already, but it's something which sometimes gets messed up, is that arrays are index-based. So you can access data by index. If I would want to get my name from personal data, which is that second element, I would do so by accessing personal data 1, because it's index-based and the index starts at 0. So the first element in an array has an index of 0, second element has an index of 1, third element has an index of 2. And that's simply important to keep in mind. It's a common mistake, because the length of that array would be 3, the highest index value would be 2. That's something you learned earlier already and what we used already, but since it's easy to mess up, I just wanted to repeat it here. Index-based, index starts at 0, the length of an array is max index plus 1 though. Now I'll comment this out, and let's move on to the next part about arrays. Let's have a look at how we can add data to arrays. Let's say we have hobbies here, sports and cooking, and now we want to add new data to that array. There are a couple of different ways of doing that actually. You already learned about one way of doing it. You can call hobbies.push and, for example, add reading here. We then console log hobbies here, and I reload, you see this has been added. And push, and that's important, always adds new elements at the end of the array. Now what if you would want to add an element at the beginning of an array? Well, that's also possible. Besides push, there also is unshift. Now might be a bit of a strange name because un sounds like it undoes something, but actually this adds an item to the array, and I'll come back to why it's named like this in a second. So here we could then also add coding. If I now save that and we reload, we see coding as the first element here added in front of the other elements. Now, we also sometimes want to remove elements, and there we got simple methods for removing the last or the first element. For example, let's say here I then want to remove the last element. Well, we can do this with pop. If we do that, if we just call hobbies.pop, and I reload now, we see we get an array with 3 elements where the last element is cooking, which is our element here, because the element I pushed at the end, reading, is popped here. Now also nice to know, pop does indeed return the element it removed. So here, since I run it on an array of strings, it will return a string. I'm not doing anything with the return value here, I just let it go into the void, but you could store the popped value here and then do anything with it if you need to. By the way, unshift and push also return something. They return a number, which is the new length of the array, and therefore if you needed that, you could of course also store that to get the new length of the array after pushing this or after adding this at the beginning with unshift. So as I said, with pop we remove an item at the end of the array. We also can of course remove the item at the beginning of the array with hobbies.shift. So we have unshift to add an item and shift to add it. Now why shift and unshift in this way? Why doesn't shift add an item and unshift remove it? Because unshift sounds way more like removing something than shift. Well, actually the naming makes sense. What shift does is it shifts all elements in the array one place to the left, so to say. That's why the first element gets dropped when we call shift. Now unshift, on the other hand, shifts all elements to the right in the end, so it does the opposite of shift, which shifts to the left. This shifts to the right. So when we call unshift, sports is moved to place 2, or into the spot of element 2. Cooking, therefore, is moved in the spot of element 3. That was reading. Reading is therefore moved to a new index at the end and becomes the 4th element. And then coding is inserted in the now empty spot at the beginning. And shift does the opposite. It shifts the first element to the left and therefore deletes it. That's why coding gets deleted. And then it will move the previously second element in the first spot, the third element in the second spot, and so on. So unshift and shift move elements to the left and right. So if we save that and we reload, we again have sports and cooking because all items which I push or unshift eventually get popped or shifted. Now also one short word about performance. If you need to unshift or shift, you need to do it. There's no way around it, I guess. But you should be aware that because of the fact that unshift and shift affect all elements in the array, they shift all elements, this operation is of course slower. So unshift and shift, these operations are slower than push and pop. Because push and pop only added the last element of an array. They don't touch any other elements of the array. They just add an element at the array or remove it. So push and pop are way faster than unshift and shift. Still, of course, if you need to add something at the beginning of the array, well, you gotta do it, right? So push, pop, unshift, and shift help us add or remove items at the beginning or the end of an array. Now, what if you need to add items or manipulate items in different places of an array? Well, for that you can use the direct index access. So here we could select the element with index 1, so the second element in our hobbies array, and of course set it to a new item. Doesn't have to be the same type as the previous item, by the way. I could set a number here, even though currently that second element is a string. If I now console log hobbies and we save that and we then reload, we'll see that now we have coding as a second element because I replaced that. So with that, we replace this element at this index. If we would want to insert an element between sports and cooking, there's a different method, the splice method, which I'll have a look at in just a second. Before we have a look at that, let's have a look at another case. What if we actually target an index which isn't set, like 5? This array only has 2 elements after all these operations, so 5 actually targets the 6th element which it doesn't have. Well, let's see what happens if we add reading here, like this. If we do that and we log that to the console, what we'll see is that here we got sports and coding, and then at index 5 reading, and we got 3 empty slots in between. Now, by the way, these really are 3 empty slots in there. If you would access one of them, let's say you do log hobbies 4 here, which is one of these empty spots, and you reload, you see you get undefined here. You get undefined here because nothing could be found in there in the end. So that's also nice to know. Now, this way of adding elements is very rare though. Adding something at an arbitrary index number where you then deliberately or not deliberately have empty spots in the array, that's not something you want to do in 99.99% of cases, I guess. So this is rarely used. Still, it's nice to know that you can directly target indexes which don't even exist and assign values to those. Now, I already mentioned a splice method that would help us insert elements between 2 elements, so between sports and cooking, for example. Now, actually, the splice method is an extremely useful method that allows us to do all kinds of things with arrays. Now, let's start with that use case of adding something between 2 elements. For that, you use your array and then you call splice on it. That, by the way, is one of the methods which is only available on real arrays, not on iterables, not on array-like objects. That might be one reason why you convert an array-like or iterable object to a real array with array from, because then on that real array you can use splice. Now, how does splice work? It takes at least 2 arguments there, but there also is another version, if you click on that down arrow here, which takes more arguments. So there are 2 different versions of that function. Now, in that version here, you specify a start index, so that's 0 based, and then the amount of items you want to delete from that index on. Now, we don't want to delete anything here, right? So maybe we start with index 0 for item 1, and then we add 0 because I don't want to delete anything. Instead, and that's now where the second version comes into play, we can add more arguments. And as soon as you add another comma, this automatically jumps to that other definition. Now you can add as many other arguments as you want, which will be items that are inserted in the place of these deleted values here. So now here, let's maybe add good food to mix it up. And then console log hobbies to have a look at that. Save that. And if you reload, you now see good food is actually the first element. Well, that happens because here I chose to start at index 0, which is the first element. Let's switch that to 1 to start at the second element. And if we now reload, now good food is inserted between sports and coding. So the way Splice works is that you tell it the index where it should start looking, including that index, and that's index 1. So start looking at the second element, then delete as many elements as I specify here, 0, and then insert this in place of that element where you started looking. So in the second element's place in this case. Now the current second element is not deleted because we didn't specify it here. So therefore it's just shifted after our newly added element here. And as I explained, you can add more than one hobby here. You could also add coding here again or whatever you want. So this is how Splice works and how you can use it to insert elements inside of an array. Of course, since you can specify that you want to delete items, you can also use it for deleting. So here we can also call Splice again. And then, for example, say that we want to start at index 0 and remove one element. And this should remove exactly the first element of our hobbies array. So if we now output hobbies here and we save that, previously we got sports, good food, coding. Now if I reload, we get good food and coding. So sports is deleted, which makes sense because we tell Splice to start at the first element and remove exactly one element. So therefore, remove exactly the first element and then be done. Of course, you could remove more than one element. You can remove as many elements as you want. If you just specify Splice like this, by the way, here, you will see that if I reload, the array is empty. So Splice without an item count will delete all items from that index on. So for index 0, it will delete all items in the array. For index 1, it would spare the first item, but delete all other items. And therefore, typically, of course, you do specify a delete count, but it really depends on what you want to do. If you want to clear an array, you can use Splice 0. If you want to delete everything up from a specific element, you would take that index of that specific element and therefore now delete everything past that element. So that's how you can use Splice as well. Now, Splice will also return something. It returns the removed elements so that they're not lost. So if your app needs it, you can now do something with these elements that were removed from the hobbies array. Now, also nice to know, Splice also works with a negative index here. You can specify -1 or -2. And what it will then do is it will go to the end of the array and look from the right. So if I specify -1, it will basically go to the, last element of this array and then delete one element. So this will, for example, delete the last element in the array. So if I reload here, we see sports and good food, but coding is gone, which was our last element, because we started at the last element and deleted exactly one. If we start at the second last element and delete exactly one, well, then we delete that second last element, which in this case would be the good food element we added here. So if I now reload, you'll see good food is gone. So negative indexes are allowed here for accessing this to access this from the right. This is not allowed for your normal index-based data accessing here on the arrays, by the way. There, where you can access the first or second and so on element, if you specify -2 or -1, you get undefined. So there, this does not work. This is really exclusive to a couple of methods, and the Splice method is one of them. So now with Splice, we already entered the world of special methods we can use on arrays. Now there are many methods we can use on arrays, and for that, I'll also comment out this code block, and I always just do that so that console here doesn't get too crowded and we can always focus on the most recent code we're writing. And I'll add a brand new array here. I'll name it test results, but the name is totally up to you. And in there, I'll have a couple of numbers, integers and floating point numbers, so numbers without decimal places and with decimal places, also some negative numbers, something like that. Really doesn't matter, just a bunch of numbers. Now we saw Splice, which is a really versatile method for adding and removing and inserting and even swapping, if you use it correctly, elements. Now another method which you can use, which has a similar name but does something totally different, is slice. So not splice, but slice. You can use slice like that, and that should be test results, of course. And if you save that and then reload this page, you see basically an array as I entered it. The interesting thing slice does here, though, is it returns a brand new array, and therefore this actually is also a nice way of copying an array. You remember, arrays are in the end objects and therefore reference values. So if you compare an array to an array that looks totally equal to us humans, it will return false if it's not exactly the same object. Also, if we store an array, stored results, in another variable, so if I store test results in the stored results constant here, then you of course see that if you output the stored results here and the test results, these will be equal even if you then added the test results and you push a new value in there. So if you add this value here to test results, you'll see that stored results are also affected if I reload. So you see this new value 5.91 is part of both arrays. That happens because arrays are reference values, and therefore what we store here is just a pointer at this place in memory, just the address of the array. So if we then change the array, well, that still points at the same address, so it points at the same changed array. That's something where slice can help us because it returns a brand new array based on the old array. So if I call slice here and I store the result of that slice call in stored results, I store a copy of that array in stored results. So a brand new array is created and stored in memory based on that old array. It has a brand new address, which is in the end stored here. And therefore now, if we add a test results here, this will not affect stored results because that stores its own brand new copy. So here, if we save that and reload, in test results, we see 5.91. In stored results, which is this first array, we don't see it. There, we don't have that sixth value. So that's one use case of slice for copying arrays. But actually, slice is also really nice for selecting ranges of an array. You can select a single element of an array with the index-based access here, 0, 1, 2, and so on. But what if you want to select two elements at the same time? So you want to select a part of your array, not the entire array, but a part. Well, slice helps you with that. You can use it like this, and it will give you the full array, but you can also specify a start and an end number, and these are indexes of the array. Start is included, end is not. So if I specify 0, 2 here, I tell slice to give me a new array, which is based on the existing array, starts at the first element, index 0, and then goes all the way up to the element with index 2, which is the third element here, but does not include that. So slice here, with this configuration, should give us this part of the array, 1 and 5.3. Well, let's have a look at that. If I now reload this, indeed we have 1 and 5.3 in that first array, which is my stored results array. So slice can be used for selecting ranges. Of course, you can start at any index, but of course the index where you end should then typically be higher than that index, though even if that's not the case, you'll see that it works, but it's now just an empty array, because, well, there is nothing between the element with index 3 and the element with index 2. It doesn't select in the reverse direction. Though what you can use are negative indexes, but then both have to be negative. So you can start at the third last element. This has negative index 1 because there is no negative 0. So in the negative indexes, the first element from the end has index 1, negative index 2, negative index 3. And then going up to 2, you might think you select this part, but this is actually not supported. This is not how it works. But you can, for example, go to -1. And this will then select from the third last element all the way up to the last element. So these two should be selected now. If we save that and we reload, indeed, that's what we get here. These two elements were selected. You can also just specify a single index here, negative or not, doesn't matter, and not specify a second argument. And this will then start at this index. So in this case, at the element with index 2, which is of course this element, and then select everything up from this element all the way to the end. So this would select this here, for example. This configuration would select this. Hence, if I save that and I reload, exactly that's what we get. Starting at 1.5 all the way up to 10, which is the end here. There also is a useful method for adding elements to an array and returning a brand new array, which again can be useful in situations where you want to create a copy of an array, maybe after adding new elements to it. Let me show what I mean. I'll comment this out and instead create stored results here by using my test results. And now here, there is the concat method which we can call. The concat method allows you to concatenate, so to add elements at the end of an array. Now therefore it's of course a bit like push. With push you can also add items to an array. By the way, also more than one item, they will be added at the end. But concat actually here takes an array or multiple arrays, but not individual numbers or items in general, but arrays, one or more arrays, and combines these arrays with this array. So it does not add these arrays as new nested arrays. That is what would happen if you pushed an array. That would add this as a single element in the existing array, hence creating a nested array. Concat, on the other hand, will pull out all elements of the array you're passing here and add them as new elements to the existing array, and it will then also return a brand new array. So it will create a copy of the array, add these items, and return that copied brand new array, hence creating a new place in memory and a new address. So here, for example, if we have 3.99 and 2, and I concatenate this here, what you'll see is, if I reload, here we got the array with 3.99 and 2 at the end, which are the two values I just added. And of course, please also note that when I push 5.91 to test results, this does not end up in my stored results, which is the first array I output here, because concat returned a brand new array. So you see no 5.91 here in the first array, only in the second one. So that's also useful. Concat can be really useful if you have array data and you want to combine it with an existing array. And the fact that you get a brand new array is also quite convenient, because that often avoids problems where you manipulate an existing array when you actually didn't want to do that. Thus far, when we worked with arrays, we always talked about adding items or selecting single items or a range of items. Now, you also encounter use cases or scenarios where you have an array of data, and now you want to find out at which index in the array a certain item sits, so that you can use that index to replace the item or for whatever reason you might have. Let's say we want to find out where in this array this item with the value of 1.5 lives. You can do this with another method that is available in JavaScript on every array. Let's run it on test results here, and that's the index of method. Now, as the name suggests, this returns the index of the value you're passing as an argument here. So for example, here we could search for 1.5. You also have an optional second argument that would allow you to specify a starting index, so that you, for example, only start searching on elements with index 2 or higher. Now, I will search the entire array here and hopefully get a result of 2, which is the index of this 1.5 value here. So if we reload this, indeed, I see 2 here. Now, there are a couple of important things to understand. For one, if you have the same value more than once, like I do here now, that I added 1.5, then this will stop after it found the first matching value. So it will return you 2, it will not return you all indexes of all items that have that value. So if I repeat that code with that new item added, you see I still get 2 here, even though I have another item of the same value at index 4. So that's one thing. Index of stopped once it found the first element that fits this description. Now, if you want to start searching from the right, there is last index of. You can use that to search from the right, and therefore it will now stop at this index. So it does the same as index of, just starting from the right. So if I now reload, we see index 4 here, because it started, well, from the right. Another important gotcha regarding index of and last index of is that it works fine for primitive values, but not for reference values. Let's say we had our person data array here, and there we have an object with name Max in there and another object with name Manuel. So it's an array of 2 objects. If I want to find out where Manuel is, then of course we could try person data index of and pass in that object, right? We could try that. If we do this and I reload my page, we'll get -1 though. -1 is the return value of index of and last index of if it couldn't find any entry. Then it always returns -1. So it doesn't throw an error, it doesn't return false or anything like that. It returns -1 if it didn't find anything. Now the reason for this behavior, of course, is this reference value thing. Objects are reference values. And therefore, in the end here, I'm creating a brand new object and I'm passing this to index of. And behind the scenes, index of is of course comparing all values to the value I passed to index of. And because two objects, even if they look similar, are never similar, it doesn't find any match and therefore it returns -1. So index of won't work if you have objects in there. But no worries, we'll have a different method that does work if you do have objects in there. So how could we fix this here and find an object in an array if index of doesn't work? Well, you have another method or two other methods which you can use in such a situation. So let's say manual is the person I want to find. Well, then you can use person data and then there is a find method. That's also a method which is available on every real array. And now find is an interesting method. It takes an argument, but the argument it takes is actually another function. Now this is a typical use case for an anonymous function, though of course you could also define a function somewhere and then just pass in a reference to that function, so the function name. But since this often is a function which you only need to run in this place and which you never call from anywhere else in your code, this is a perfect scenario for an anonymous function. Now, of course, it's not just a function like this which does nothing. Instead, it's a function that can accept up to 3 arguments. The first argument will always be a single object of that array. So we could name this person. You can choose any name you want here. The second argument will always be the index of that single element. So you could name it index or IDX or whatever you want. The third argument will be the full array, so persons, for example. Now, who's calling that function? JavaScript will call it for you, so to say. Find executes on this array, and what it does is it executes this anonymous function which you pass to it, or this function in general which you pass to it, on every element in person data. So it will execute this function here on every element in person data and will then, for every execution, pass in, well, that element it's currently looking at, then the index of that element, and then the full array. Now, of course, you can also use find on any array, even if it's an array full of numbers or text. It's not restricted to arrays full of objects. That's just a use case where it's particularly helpful because it can help us identify an object or a value if it's a reference value, because for primitive values, often index of helps us get what we want. Though that of course returns the index, but then we could use that index to easily access the value behind that index, right? But back to find. So we execute this on every item in person data, and it then expects that this function, which you pass to find, returns true for the element you're looking for, so for the element you're trying to find, and false for all other elements. So in here we have to return something, and that should be a Boolean. So typically in here you have some kind of comparison. So we could compare person.name, because we know we execute this on an array of person data, so we have a bunch of objects in there which have a name property, and this is a single element of the array, don't forget that, so it will be an object with a name property, and we can check whether that is equal to manual, for example, in this case. And this should find us that one object where the name is manual. Now, if you have multiple objects with a name of manual, it will still stop after the first hit, just like index of. It will stop after that and not return all fitting elements, but only the first one. So find returns us manual. Here, therefore, I'm not even using that index or that entire array, and quite often you'll not need that, but if you need it for some reason in that function, you have it available. And therefore now if I console log manual here, we hopefully console log a JavaScript object which is, well, having a name of manual. So if we now reload, that's looking good. Now one important note about find, it returns the same object as you have in the array here. It does not copy it or anything like that. So if I then would manipulate manual's name here and set it to Anna, which is a pretty drastic change, I guess, but let's still do it. Then I will not only see that here when I log manual, but also if I log the entire person data array again. If I do that though and I reload, you see here we have Anna, but we also have that here in the array because we're working with the same reference value with the exact same object. That's important to understand. Find does not create a copy. Now, just like find, you also have find index. So you can get Anna or max index here by using person data find index, and then it takes the exact same function, so exactly in the same way. Now I just want to look for max here, and the difference is that it will not return the matching item of the array, but the index of that item. So if I now console log max index down there, we should see 0 because that max object is the first element of that array and therefore has an index of 0. So if we save that, reload, indeed here we see 0 being printed. So that also works. So that's find and find index. There also is another useful method for finding out whether it is part of an array or not, and that's the includes method, though it's also most useful for primitive values because it also just checks values like index of does. So just wanted to throw this in here real quick. We could, for example, check if test results includes a value of, let's say, 10.99, which it does. This will then return true or false, and therefore includes is a great choice if you're not interested in the index and also not interested in the value, but just want to know whether it's part of the array or not. Though it's important to keep in mind that index of will return -1 if something wasn't found. So this is essentially the same here as running index of and comparing that to not being equal to -1, because if that is not equal to -1, we know that it exists. If it is equal to -1, it does not exist. But of course, that's a bit shorter and saves us this extra comparison. So if you only are interested in knowing whether it's part or not, includes is nice to have for primitive values. So here, if I reload, I see true twice because it is part of that array. Time to comment this all out again and dive in more examples. So let's say here we have another array, prices, where we have a bunch of numbers like this. And now we want to do something with every price. We want to add tax on it. So we might have a tax here. Germany, that's 19% value added tax. And now we want to get the adjusted prices. So tax adjusted prices is an empty array initially. Now what we can do is we can add a for loop and go through all prices like this here. And then we could push a new item onto tax adjusted prices. We can do that despite it being a const because it's a reference type and we never assign a new value to that constant. We just change the data in memory. Check out the behind the scenes module if that's brand new to you. There I talk about that. So now we can push a new item onto it, and that would be price times 1 plus tax, for example. And if I then console log the tax adjusted prices here, that will just work. If I now reload this, here we have the tax adjusted prices. Let's ignore this strange float value here. That's something I'll come back to in a numbers deep dive section. It's not a bug or anything like that. It's just some number imprecision computers can have with floating point numbers. So generally that all works, though that's the main takeaway, and there's nothing wrong with that. There just also is an alternative to the for-off loop, not saying though that anything is wrong with the for-off loop. But if you would, for example, need the index for some reason, then you don't have that available here in your for-off loop. Instead, you could use a regular for loop, of course, where you manually manage the index in the end, or you just use another nice method you have on arrays, and that's the for each method. The for each method, just like find and find index, takes a function, and that function which it takes 3 arguments, or up to 3 arguments. The value it's currently looking at, because just like the function you pass to find and find index, this function executes for every element in the array. So here we get our price, let's say, then the index or IDX or however you want to name this argument, and then the full array in case you're interested. But I won't need it here. Just for completeness sake, I'll add it here. By the way, the fact that I use the same name as I do here is not an issue here because of shadowing. This has a different scope here, right? It has its own block scope in the end. This is in the end like a variable of this block, so it has its own scope. And therefore, if I use a name that's defined outside of it, well, for inside this function, this outside constant is simply overridden. Not here, of course, so this will work just if I would try to access it from inside the function. Of course, you could also pick a different name here for prices, but due to this shadowing process and block scope, it also won't be a problem. Well, and now in here, we could do the same thing I did in my for-off loop. So of course, the only difference therefore is that I, well, don't use for-off, which on its own isn't necessarily an advantage, but the advantage could be that if you need it, you have the index available here. So if you also would want to transform your entries to objects where you store the index, that would be fairly easy to do here. Price object could be an object where you have the index, which is now that IDX value, and then the tax adjusted price, which is that price we're calculating with that formula. And then we could push the price object here. And now we got access to the index, which we don't have in the for-off loop. So with that, if I now save that and reload, we see we now have an array of objects with index 0, tax adjusted price, index 1, tax adjusted price, and so on. So that's for each, an alternative to for off, which has the extra benefit of giving you easy access to the index, and in general, simply an alternative you could use instead of for loops if you want. Using for loops is not bad though, both is possible and simply an option. Now in the end, what we did here in the last lecture with for each is we transformed the array, right? We in the end transformed it from an array of prices into an array of objects where of course also each price changed. We can do that with for each here, but there is an easier way, because what we have to do with for each or with for loops is we have to manage our new separate array onto which we push these transformed items. We can't do that, but there's a shorter alternative. So if I copy that and then comment it out and repeat this example, let's get rid of the text adjusted prices array like this. Let's get rid of this comment here also to save some space. And now instead of for each, we can use map, another special method available on arrays. Now map has the job of taking an array, running a function which has this form on every item in that array, and then, and that's important, that function should now return a new element for every element in that array, a possibly transformed element. So for each, this function which you pass to for each doesn't have to return anything. You can do whatever you want in for each. For map, this function which you pass to it has to do something, has to return something. It has to return the mapped, the transformed, the new element for that array. So here I would return price object, for example. And that means that now this will replace every element in the array on which we call map with this adjusted element. However, that's not totally true. It doesn't really replace it. The original array stays untouched. Instead, it returns a brand new array with a brand new address in memory where every element has been changed. So now here we can get our tax adjusted prices stored in a constant, and prices themselves will be untouched, as I can prove by logging them here. Tax adjusted prices, however, will be the, well, transformed prices with the help of map. So if we save that and reload here, we see that is the original array, nothing changed there. And here we have the transformed array with our objects in there. So that did indeed change. So map is a really nice method if you want to transform an array, because it makes changing elements and getting a brand new array based on these changed elements super, super easy. There are two other ways of transforming an array. let's say instead of getting our tax adjusted prices here, we're happy with the original prices array, but we want to sort it because right now, as you can tell, it's clearly not sorted. For that, you have another method which you can call, and I'll store that sorted array in a new constant sorted prices, and you call it on an array, just like map and so on, and that's the sort method. Now this will sort the array, and let's see what this gives us. If we console log sorted prices here and save that, and I reload, these are my sorted prices. Well, are they? This does really look sorted. It's certainly not the original order though. There 5.99 was the second element, now it's the third one, but it's also not sorted correctly. Well, the thing is, sort by default converts everything to a string, and then it simply sorts this in a string logic, and there 1 is smaller than 3, for example. This is how it sorts it. Now that's not what we want here. The good thing is you can pass your own function to sort, a function which takes two numbers, a compare function in the end. You can label these parameters a and b, but the name is up to you. And what this does is, it executes these functions on pairs of elements here. And it always gives you these two elements, which it's currently comparing. And then you should return for that pair of elements, which it is comparing, whether a, so the first value, is greater than b, if they're equal, or if b is greater. And then it will swap these two values, if needed, based on that, and move on to the next pair, so to one of the values it just swapped and the next value in line. Let's see it in practice, because that will clarify things. So here we can add an if check in that function, because we'll need to return one of three values. Is a greater than b? Are they equal? Or is b greater? So let's check if a is greater than b. What you return in that case is 1. So you return 1, and it should be 1 if a is greater than b. Else if a is equal to b, and it's up to you whether you use a triple or a double equality check here, depending on which kind of data you are sorting, you return 0. So if they're equal, you return 0. Well, and you can probably guess what you return in the else case, which is that b is greater than a. Well, then you return -1. So 1, positive, if a is greater than b, 0 if they're equal, -1 if b is greater. And if you now do that, and you reload, now this looks much better, and now we have a correctly sorted list here for our number logic. Now, of course, which logic you have in here, in your function you pass to sort, totally is up to you and depends on the kind of data you have in your array which you're trying to sort. Here, for numbers, such a comparison makes sense. You could be checking anything in here though. Now that sort, kind of related to it, is another function which you can call on arrays, and that is reverse. Well, and this does just what it sounds like. You can't pass any arguments to it, it simply reverses an array. So here I first sort the array, and then I output the reversed array. So hence if I reload now, we get the highest number first and the lowest number last. Now side note, here of course I'm just showing that to show you reverse. If you indeed do find yourself writing such code, it would always be better to just inverse your sorting logic. This would also sort from highest to lowest and save you that extra reverse call here. Right, so no need to do that double sorting and reversal if you can just adjust your sort logic. So this here also yields the same. I just wanted to show you reverse here, and of course it's good to know reverse because you're not always sorting. Sometimes you have an array which generally has the right order, just for this specific use case you want to reverse it. Well, then reverse is your friend. Now slowly we're coming to an end of interesting array methods, but we're not there yet. Another very useful array method is one that allows you to filter the elements in an array. Now we had a look at find and find index, which was really nice for finding single elements, but what if you want to basically reduce the amount of elements in your array based on some filter? Let's say here we only want to have prices that are greater than 6, so that only 6.59 and 10.99 are included. Well, for that we can create a new constant, for example, filtered array, and then use the prices array and call the filter method on it. Now just like all these other array methods, filter will return a brand new array, so it will not touch the original array, but instead return a new one, which we then store here, and which I therefore want to output down there. And the filter method also takes a function. And this function here works just like the function you passed to find and to map and so on. You get the value it's currently looking at because this function which you pass to filter is again executed for every item in the array on which you call filter, so on every price in this example. You get the index here, and you get the original array if you're interested, though you will rarely use that last argument, as you already saw here. Well, and then here again you need to return something. So the filter method is a method that expects the function which you pass to it to return a value. To be precise, it wants true or false. It wants true if the item on which this function is currently executed should be kept in the newly created array, and false if it should be dropped. So here I want to keep everything where the price is greater than 6, so I will return price greater 6. This Boolean comparison here will return true for any item where the price is greater than 6, and therefore any item where the price is greater than 6 will be kept, other items will be dropped from that newly created array. The old array is not touched, so the prices array itself is not touched. So if we save that and reload, filtered prices here indeed only has two values, which are my two values greater than 6. So filter is also really useful for, well, filtering an array, as you can guess, and therefore this also is an operation you'll find yourself do quite frequently. Now at this point of time, I want to talk about arrow functions real quick, because here we can really see why they shine. With arrow functions, you can shorten this code a lot. It's already quite short, and it would definitely be longer if you had the function keyword here. But with arrow functions, the examples like this one, where I really only use the price, we can drop the other two arguments. Therefore, we can drop the parentheses, as you learned. And since we only have one expression in there, we can even drop the curly braces, like this. Then we also have to remove the return statement, and also the semicolon, and instead write this code. This expression's result will then be returned by the function automatically. And if this isn't short, well then I don't know what's short. This is super short and concise, and of course you could even make it shorter by shortening this argument name. Of course you should try to still make sure it's readable and understandable, but this should be understandable. So this is how short this can be. And of course there are other places in the code we wrote thus far where you can also shorten your functions. So that's why arrow functions really are a great addition to JavaScript in general, and why they really shine when we talk about these array methods. It's just something I wanted to highlight here because I often write a bit more verbose code to be as understandable as possible, but this is also what you can do, and this is super short and concise, as you can tell. Now there is one last important array method which you absolutely have to know. And that's the reduce method. Now I'm diving into it last because it's one of the more complex or challenging functions, but in the end it's also pretty straightforward, and I will explain it step by step. So let's assume here, with your prices, let's say the unfiltered, unchanged prices, you want to sum them up. Now of course what you can do is you can create a for loop, or you can use for each, and you could create a sum here. Whoops, let's sum. Set it to equal, and then you could go through your prices, let's say with for each, where you have the value of each price, and then here in the end you say sum plus equal price, right? And if you do that, and you console log the sum thereafter, we should have, well, the sum of all prices. So that's not too much code, and if I reload this, well, this probably is the sum. Again, let's ignore this strange output here. I'll explain it later. It's not a bug or an issue, just related to how computers work with floating point numbers. So I added these values together and I got a sum. Now, of course, that's not too difficult or not too problematic here. It's a quite short code snippet. But we can actually write this with less code. Let me comment this out. And instead, create a constant sum and set this equal to prices.reduce. Now the reduce method is another built-in method available on arrays, and the reduce method takes a function. This function, as you can see, takes a couple of arguments. It takes a so-called previous value, okay. It takes a current value, okay. It takes a current index if you want to, and it also accepts this original array on which you're running it. Now, I will say that current index and that array, again, are the arguments you don't use that often here. The index maybe sometimes, this original array pretty much never. I'm just adding all arguments here for completeness sake. The first two arguments are the really important ones here though. Now the reduce method itself also takes another optional argument or parameter. So the first argument or parameter is this function, and you must never forget, we're always passing functions here as arguments, as parameters to sort and so on. So here I'm passing a function to reduce, and then reduce itself does not just take this function as its first parameter, but another optional second parameter. Now what does reduce do to begin with? Reduce, as the name suggests, reduces an array to a simpler value. For example, it can reduce an array of numbers to the sum of these numbers. Of course, that's not the only kind of reduction it can do. You can reduce any array to any value you need. So the idea always is that you reduce an array to a simpler value. Typically an array to a single number or a single string or whatever it is. Now, the second argument you pass to reduce is the initial value with which you want to start. So here, if we want to get the sum, we would start with 0 probably here. Now what happens is, reduce executes this function on every element in the array, just like map and find did, and previous value for the first execution is this initial value which you set here, if it's set, otherwise it will be undefined. Current value is the first element of the array. So generally the element of the array it's currently executing on. So for the first execution, current value is the value of the first element in the array, previous value is this initial value. Now here, in this function, you have to return your updated value, so your currently reduced value. So that in this case here would be previous value plus current value. So for the first execution, previous value is 0, current value is, well, the first element in prices, so current value would be 10.99. So now for the second execution, this function here is executed on the second element in the array, which in this case is 5.99. Now on that second execution, previous value no longer refers to that initial value, but instead to the value you returned in the previous execution. So in this case, since we're on the second execution, previous value will hold the value of the first execution. So the result here of that first execution. Now remember, in the first execution we had 0 plus 10.99 in the end here, because 10.99 is the first value. So in the second execution, we'll get this 0 plus 10.99, so 10.99 in total, value as a previous value. And now this 10.99 value is what we use in this calculation here to add our current value, which for this second iteration is the second element's value, 5.99. So now we add 10.99 plus 5.99, and so on for all elements in the array. Here's a graphical representation of what happens. Let's say we have an array with the values 1, 2, and 3, and we want to reduce it. We might start with an initial value of 0. Of course, you can start with any initial value, but let's say we start with 0. And now the reducer function executes. Now this means it has a look at the first element, so to say, and it returns this initial value plus that first value, which is 1. Now this is fed into the second execution, where we have a look at the second element, so the reducer function returns 3. 1, which was the result of the first execution, plus 2, which is that second element we're looking at. And then we will repeat that one last time, where we have a look at the last element of that array, and hence we get 6, because we had 3 as a result of the last execution. 3 also is our last element in the array, so we have 3 plus 3 equals 6. Now, of course, the original array is not emptied or anything like that. I'm just removing the numbers we worked with here to make this slide clearer. The original array is not edited in any way. Instead, this only executes this logic on all array elements to gradually build up a value which you in the end return. Well, and for the last execution, if there are no array elements left, well, this value is returned overall and is stored in this case in this sum constant, which we can therefore log. And hence what we see here, if I log this, is the same result as before, which makes sense. It would be bad if we had a different result. Now, just as before, you can also shorten this thanks to arrow functions. We only need the first two arguments, so we can get rid of the other two. We need to keep the parentheses here since we have more than one argument, but we can get rid of the curly braces like this, then have to get rid of the return value and just write it like that, get rid of the semicolon, and have a very concise reduce function, which really just reduces this array of numbers to a single number. That's just one use case, but reduce can be really powerful for combining values in an array, well, to a single value. So that's basically it for all these special array methods. Now there are two other special methods which are related to strings, and they're also quite handy. Let's say you have some data which you maybe read from some CSV file, which looks like this. New York, semicolon, 1099, semicolon, 2000. Whatever value that might be, but you have that value. You might want to transform this to an array where you have 3 separate values instead of one single value like this. Actually, this of course shouldn't be an array, it's just a string. So instead of having a string with this combined data, which to us humans is clearly recognizable as 3 different pieces of data, you might want to split it into 3 real elements with which you can work on the computer as well. For that, the transformed data can be created by running data.split. Now that's a string method, not an array method, because data is a string, not an array. Now split splits a string into an array of multiple segments. And as an argument, you specify the separator by which you split. That could be a white space, so blank, underscore, comma, any arbitrary character, or of course also a semicolon. And this will now split that string into 3 elements. After every semicolon, it will pull out a new element, and split therefore returns an array with these elements into which this string was split. You can also specify an optional second argument to limit the number of elements which is created. But here I don't want it, I just want to split it like that. And therefore here, if we console log the transformed data like this, and we save that and we reload, we indeed have our array with these 3 data pieces. Now, of course, if you would want to transform numbers to real numbers, you would have to do that as well with parseInt by then diving into that transformed data and, for example, using the map method to transform some elements, or targeting them by index and setting that equal to plus transformed data 1, for example, to replace it with a real number if you wanted to. These are things you can do, as you can tell, but the split method is the main thing I wanted to focus here, as it allows you to split a string into an array. Now you also have the opposite kind of operation. Let's say you have the name fragments constant here, and that has Max and Schwartz. So that could be a first and a last name. And you had this as an array because maybe you pulled this from 2 different inputs on the screen, and now you want to merge this together into one string, which you can use in your user interface to greet the user or anything like that. Well, then merging this into a string is very easy by using another special array method now, because name fragments now is an array, not a string. And there you have the join method. Now join also takes a separator, which you can use to join these things together. Now let's first of all join without a separator to then see the difference, and console log name. So this should now join the elements of this array into one string, and it will always generate a string. Even if you had numbers in here, it would still work, but it would convert everything to a string. So if we now save that and we reload, indeed we see Max Schwartz, and you see by default it separates the values by a comma. Now that might or might not be what you want. If you want some white space, for example, you simply add this as a separator here, so as an argument to join. And if you do that, now the elements of this array will be joined together into a string with this as a separator between the individual words in the string in the end. So now if we reload, we see Max Schwartz like that. So join and split also are very helpful for transforming strings to arrays and arrays to strings and making sure that you got machine readable data and human readable names. That's the idea here. More about arrays. Now here for one I noticed a little typo. Of course that should be fragments, not fragments. Sorry about that. And now let's dive into more interesting JavaScript features related to arrays. To be specific, into two syntax features which help us work with arrays. Now, one is a feature which I already briefly introduced but didn't dive deeper into. Well, now is the time to dive deeper into it. And that would be the spread operator. In case you forgot it, the spread operator is an operator that in the end pulls out all elements of an array and, well, gives them to you as a standalone list of elements. So if I, for example, do name fragments, I'm pulling out all the elements of that array, but using it like this is actually not supported. Here I'm pulling out all the elements of the array and I'm not doing anything with that. I also can't assign it to a constant like this, because that would just be as if you had Max Schwartz here like that, and that would be an invalid syntax. This is not a supported operation. What would you do with just a comma separated list like this? Instead, where you use this spread operator is, for example, to copy an array. So if I have my copied name fragments here, then I can create a new array with square brackets, an empty array, but now populated with the elements of name fragments, but not by adding name fragments like this. This would insert this name fragments array as the first and only element in the copied name fragments array, so we would create a nested array in the end. But instead we add these 3 dots, which make up that so-called spread operator, which is like that rest operator you saw in the functions module, but simply used in a different place. In the functions module, we used these 3 dots, the rest operator, in the argument list of a function. Here, I'm using that in a place where I need multiple elements. For example, when we initialize an array. This will then pull out all the elements out of the name fragments array and add them as individual elements to that newly created, otherwise empty array. And then copied name fragments is a new array, because we created here with square brackets, with the values of the old array, so with these strings here in that case. And the consequence is that if I log name fragments here and I log copied name fragments here, we'll of course see that if I reload, we get the same array here. But it's interesting that if I now go to name fragments and I, for example, push a new fragment here, MR for Mr., let's say, and I reload, we see that this MR element is part of the first array I output here, which is the name fragments array, which is the one where I pushed it to, but it's not part of that second array, which is my copied array, where I indeed created a brand new array and just added the existing elements. Therefore, if I added array 1, name fragments, this array 2, the copied name fragments array, which is a copy and therefore a brand new array, is not touched at all. So that's one advantage, but you don't just use this spread operator for copying things. If we go back to our prices, which we have up there, then you see this is an array full of numbers. Now you also have some functionalities in JavaScript. For example, on the global math object, which we'll have a closer look in the numbers module later, where you have a min method. The min method takes a couple of arguments. It does not take an array. Instead, it takes values like 1, 5, -3. And then it will return the smallest value. So if we console log that and reload, we of course output -3 because that is the smallest value. Now, if you would want to find the minimum value in your prices array, then you would have a problem normally, because that is an array, not a list of values, not a list of arguments, so to say. So if I pass in prices like that and I save that, this doesn't work. I get not a number because indeed I passed in an array, not a number, and it only works with numbers. So here, again, we can use the spread operator to pull these elements out of the array so that we have a comma-separated list of elements, and that's exactly what the min method here requires. So also for situations like this, where you're working with some function or some method that requires a list of standalone values, the spread operator helps you get these values out of an array. And therefore now, this indeed returns us the minimum price here. Now, one important note about the spread operator, and especially about copying arrays with the spread operator like this. When you copy such an array, indeed when you added the original array, the copied one is not affected, as I showed you. Now, one common mistake is that you copy an array of objects. So for that, let's create a person's array here, maybe, where we have objects with name Max, age 30, and another object, name Manuel, age 31. Now let's say we want to copy that. So copied persons, of course, can be created by adding square brackets and then using the spread operator on persons like this. Now, unsurprisingly, if we console log persons and copied persons like this, you will see that if I go to persons and I push a new person into this array, let's say Anna, aged 29, that this will be part of persons but not of copied persons, because copied persons, as you learned, is a brand new array, and therefore changes to the original array are not reflected in the brand new one. And indeed, that is what we see here. The second array doesn't hold this Anna object. Now, a common mistake is to think that the objects in the array, which are also reference values, are also copied, and that's not the case. We're copying all the elements of the array, which means we're copying the addresses of these objects in the end. So whilst we have a brand new array, the objects in the array, the objects in that brand new array are still the old objects, because in the end you must never forget you're working with reference values, and therefore in the end this is an array full of addresses to the places in memory of these objects. So you are copying all these addresses here. Hence, if we would go to persons, and there let's say to the first element, which is Max, and change the age to 31, you will see that this change is also reflected in copied persons. If I reload this, we have a look, expand this is copied persons, and you see the age is 31. Now that happens because I copied the address to the place in memory, and here I then added this object in that place in memory. So since we here only copy these addresses and create a new array but no new objects, of course any edits to these objects also affect our persons in the copied array. And that's not a bug or anything like that. This is the intended behavior. If you would want to avoid that, you would have to copy every object here as well, which you could achieve by using the map method, for example. So here on persons, we map that to get a brand new array, and then we pull elements out of that returned brand new array. And now in there, we get a single person, and now we can return a new object for every person. So then here, we could return an object. And side note, since I return something in curly braces to tell JavaScript that this does not mark the function body, but should be my object, I have to wrap this in an extra pair of parentheses. This will then tell JavaScript that this here is the single expression function body. So I just return something immediately, and this here does therefore not mark the function body, but instead marks the object which I'm returning. So here I can then return a brand new object where name is equal to person.name and age is equal to person.age. So I keep all the data of the original person, but I wrap it into a brand new object. So the same logic in the end as I do it for this array. I create a new array and keep all the original objects. Now I don't really do that. Instead, I map all objects in the original array into new objects, which therefore have new places in memory, and then map gives me a new array, as you learned, and I pull out all the elements of that new array that map returns and merge them into this yet another new array with these square brackets. And therefore, actually, here you could omit that. You could just save the result of map here, because map already returns a new array. So now we would have a new array with new objects in there. But even then, if one of these persons had a hobbies key, which is an array, then you would have the same problem. You would clone the object, you would clone the outer array, but any inner reference value fields are not copied. Now, this is not necessarily a problem. Of course, you could now find ways to then clone the hobbies as well, right? You could say hobbies equal to new array, where you make a copy with the spread operator. But you can do this, well, infinitely, depending on how many nested reference values you have here. That's not really the goal. That's not really what you should aim for. Instead, only copy what you plan on changing, where you don't want to have these changes reflected in the copied value, in the copied array, or whatever you are copying. That is how you should think about that. So it can be tricky. In the end, the spread operator is a very useful tool for copying, for distributing elements into the argument list of a method. And when you do copy, keep in mind what I just explained about nested reference values, and that you might need to copy these as well, but only if you copy these as well and you don't want the changes to these nested reference values reflected in your newly created copied array or whatever it is as well. So that's the spread operator. Another very nice syntax feature is the array destructuring syntax, which you can use. Now, for that, let's go back to my name fragments here. We have Max and Schwartz here. This is a perfect example for where array destructuring might be useful. You could be getting this from some other function, let's say, that reads some values from some inputs you have on your web page. And now you get this as an array, but you want to split it into two separate variables with which you continue working. So you have your name fragments, and to make this easier to read, I'll comment out all of that here actually, so that we have less output in the console, and recreate my name data, name fragments, however you want to call it. So it's Max and Schwartz, and this clearly is my first and my last name. Now, in the rest of your code, you might not want to work with this array, but with the individual values. Of course, you can always access the individual values by their index, but always writing name data 0, name data 1 just to access these values is a bit cumbersome. So of course you can store that data in new variables or new constants. First name could be name data 0, and then the last name could be name data 1. And that is absolutely fine and works. Nothing wrong with that. Now, there is a shortcut for that though, and that's exactly what array destructuring is all about. You can write this a bit differently. You can add square brackets here after const, so on the left side of the equal sign, which is something we haven't done before, and point at your array. And now what you put between these square brackets are variable names for the elements in the array on the right side. So this array has two elements. So here we can add any names of your choice, for example, first name and last name like this. And what JavaScript will do is it will pull out the elements here and store the first element in a variable, or in a constant in this case, of this name, and the second element in a constant of this name. So therefore now if you console log first name here and last name, and you save that and reload, you see Max Schwartz is getting logged here, but this is now really stemming from these two individual variables which are output. So that's a very powerful syntax for splitting an array into variables with which you want to work. Now sometimes you also have more data in the array than you want to pull out. Let's say we also have a Mr. identification element in name data, and I'm only interested in first name and last name. If I save this and I reload, this works, so we can leave it like this. And if you maybe also want to collect all other information which you have, let's say we also have the age here, well then you could add another variable here, other information, or however you want to call it, and add that good old rest operator here. Now here I'm calling it rest operator because what it will do here is it will collect all remaining elements of that array which are not assigned to variables and store them in one brand new variable, which will be a new array that is in the end created. So here, other information, if I output that as well and we reload, now we see other information indeed is an array with the two remaining pieces of information which we don't assign to separate variables. So you can also do that if you want to kind of collect the remaining data and store that in some, well, array that holds all the remaining data. Now, needless to say, this destructuring syntax is read and assigned from left to right. So first element here gets the first element in the array, second element gets the second element, third element the third, or if you use the rest operator, any elements after this element, so all the remaining parts here, are merged into this array. So array destructuring is a really neat feature if you want to split up an array into variables or constants, which you then can use throughout your code. It simply saves you the extra work of doing this manually and therefore can speed up your development process. That is it for arrays. Lot of information about arrays, lots of things you'll of course see throughout this course and in many of the projects you will work on as a JavaScript developer. Now definitely of course take the time to go through these things again, have a look at some of these important array methods, get acquainted to them, practice with them, get a feeling for them. For now I will move on to totally different constructs or iterables though, or not totally different but quite different, which also exist besides arrays. And that are maps and sets. So in JavaScript, we got three major iterable data structures, you could say. We got arrays, but we also got sets, and we got maps. Now, one important thing right away. Arrays are the most important one, the one you work with, well, most often. And objects, of course, but objects also are a bit more than just a data container. Something you'll especially see once we dive deeper into objects in the Objects Deep Dive module. So when we talk about lists of data or storing kind of connected data, arrays are the main storage for storing that data, and there you can have nested data of any kind, of any length. You can mix data types. It's an iterable, as you learned, with many special array methods available, all these great methods which we used. And a couple of key characteristics of arrays are that the order of elements is guaranteed, so the order doesn't magically change. Duplicates are allowed. You can have the same number twice in an array, for example. And you have a zero-based index to access elements. These are things you, of course, learned throughout this course and especially throughout this module. Now, what are sets then? Sets are also data structures which store nested data of any kind of length. So you can have sets of arrays, sets of numbers, anything goes. And it's an iterable with some special set methods, but not with all these array methods. So these array methods are not supported on sets. Instead, there are standalone set methods, which are mostly there to manage the data in the set, though, not for transforming it and so on. Though you can always, what you already learned, convert any iterable to an array with the array from method. Now, what are the key characteristics of a set, and how does it differ from an array then, other than that it misses some methods? Well, in a set, the order of elements is not guaranteed, which might sound bad, but that isn't necessarily a problem. You don't always need a specific order. And also important, duplicates are not allowed. This makes sets a great choice to store data where you don't want duplicates for unique IDs or anything like that. You also have no index-based access. Instead, you just have an access that allows you to, well, get a specific value if you're looking for it, and then you can see whether it's in the set or not. Now, maps are yet another data container where you store key value data of any kind and length. And that's a bit like an object where you also have key value data. One important difference is that in an object, you may only have strings or numbers as keys, or symbols, but we haven't learned about those yet. In maps, you can use anything as a key. You can have an array as a key, you can have another object as a key, and that offers you more flexibility. It's an iterable with some special map methods, but not with the array methods. Again, just as with the set, the methods which you have here are mostly there to help you manage the items in the map. And here, the order is guaranteed. That's, by the way, not the case for objects. There, the order of the key value pairs is not guaranteed. Often that doesn't matter because you retrieve values by key anyways and you don't care where it's stored. Well, nonetheless, here it is guaranteed. Duplicate keys are not allowed, but values can be duplicated throughout this map, and you access values by key. So let's now work a bit with these data structures and then get a feeling for when we use them and how we use them. For that, I'll create a brand new script file, sets maps.js, because the other file is pretty crowded already and I want to have a clean one, and import sets maps therefore, and not the app.js file anymore. So with that imported in here, let's start with sets. Let's create a new set of, let's say, IDs, because that is a super example. IDs should be unique, and therefore you might want to store them in a data structure where you can't have any duplicates. You create a new set always with new set. You saw new array earlier, and there I told you that this is not a great idea and you should use square brackets instead. Well, you have nothing similar for sets. There you have to use new set. Now you can create a set like this, which would be an empty set. Let's log it to get a feeling for how that looks like if we save it and reload. This is how it looks like, an empty set. And you can alternatively also initialize it by passing in an existing iterable. Any iterable goes. So it can be an array, can be another set, can be a node list. So here I'll pass in 1, 2, 3, an array with the values 1, 2, 3, and save that. And if we reload, now indeed we have that in the set. Now here we see index values 0, 1, 2, but we don't really have access through these values. If we try to access this index 1, let's say, like that, you will see that this returns undefined. So this doesn't work. It's just here in the console. Instead, to retrieve a value from the set, you can use one of these specific set methods, which you see if you type a dot here, and then you get this auto-completion. You got add to add a new entry, clear to clear all entries, delete to delete the single entry, entries, which I'll have a look at in a second, for each has keys, values, and so on. Now, what you don't have here is a method to get a value. There is no get method or anything like that. Well, if you think about a set, since every value can only be stored once there, you typically don't want to retrieve a value from there. Instead, you can check if it has a certain value, if 1 is stored in there. And if it is, well, in your subsequent code that depends on this existence in the set, you can just continue with 1. You can just use this value of 1 because you know it's in the set. This will return true or false, and therefore you can use it in if checks or ternary expressions. And this is how you work with a set. It's a data storage that basically tells you whether it contains something or not. Now, interesting is if we add a value. Let's say we add 2 here, which is a value that already is part of the set here. So if I now check if it has 2, and I reload, I get true, but we don't know how often it is stored in there. Well, let's again log the entire set therefore to get a view into it. And indeed we see it still has only 3 elements. The value of 2 still only exists once in there. And the reason for that simply is that, as I mentioned on the slide, in a set, a value is guaranteed to be unique. Now, if you would want to go through all elements in a set, you can do that with ids.entries. ids.entries, entries is a method which you can execute, and it returns, as you can see, an iterable, which means you can use it in a for loop, in a for of loop. So you can go through entry of IDs entries and console log entry here, like that. If you do that and you reload, you see what you get is actually a couple of arrays, which look quite strange here with these numbers. It gets clearer what these arrays mean if we change 1, 2, 3 here to different values like hi, from, set, which is of course not your typical set usage, I guess, but let's say you want to guarantee that each word is only part of the set once. If we save that and we reload, now we see this output here, hi, from, set, and then 2, 2 here because I add this there, right? And as you can see, therefore, we can have mixed value types in a set. So what do we actually get here? We got something where we have the value twice, basically. Well, that's just what entries returns. It returns an iterable of arrays where you always have exactly 2 entries, or elements per entry, I should say, and that's simply the value twice, which might sound strange. Why would you have it twice? Why would it give you these arrays where you have the same value twice? Well, this is there to be in line with the entries method on the map, which we'll also later see, where you also get 2 values, but there they will be different. So I guess the idea here was that you could easily swap a set for a map and keep your other code in place, and therefore have the same signature here, where you get an entry with exactly 2 elements, even though for a set, entry is an array of the same value twice. So it's just a bit confusing right now. In the end, if you want to go through all values, you can just access the first element in the entry. Since the second one is exactly the same, you could of course use that as well. And you then log all the values you have in that set. So this allows you to read the values from a set and not just get the information whether something is part of it or not. And with that, you can manage this set. Now, if you want to delete something, you can also do this, for example, with the delete method, and then enter the value you want to delete, like hi, which should delete this string. If you try to delete something which is not part, you'll not get an error, as you see, but it will just not do anything. It's basically ignored. The same as if you add a value which is already part. You don't get an error, it's just ignored. But of course, you typically want to delete what you have, and you could always check if IDs has hi before you try deleting it, though since this won't throw an error if it fails, there might not really be a need to perform this extra check. Still, here to also show the has method, this is how we could ensure that we only try to delete what's part of that set. So now with that, since I'm deleting hi, if I reload this, hi should no longer be output there because it's no longer part of the set. So to summarize, sets are a data structure, or are data structures, which help you manage unique values. And in some cases, that can be useful. Now, as I mentioned earlier already, the array is the most important data structure, so you will probably not use sets everywhere. But if you have an application, a more complex application, where you want to manage, let's say, IDs, which are already in use by logged in users, then you could use a set to keep track of these IDs, and you might want to use a set instead of an array because you want to ensure that a single ID can't be part of the set more than once, so that it doesn't get too big, doesn't consume too much memory, or leads to other logical errors you might have in your code. So sets are great if you need uniqueness amongst your data. So that's sets. What about maps? So we had a look at sets. Let's have a look at maps then. Let's say we have a person here, person 1, which has a name of Max maybe, and another person, person 2, with a name of Manuel. Now these are not maps, these are normal objects. Now a use case where you could use a map is that you want to attach some extra information to each person here, but you don't really want to merge it into this object because you use this object in multiple places of the application, maybe you even copy it, and you don't want to bloat it with this extra information, and you also want to make sure that in other parts of the app where you work with this object, you have a lean object to work with without too many properties where you have to guess which one you need in this case here, and instead some extra information which you might need in another part of your application could be managed in such a map. So we could create a constant or a variable person data, and you now create a new map with the new keyword and then map. So just like set, but with, well, map. Now this map constructor here can be initialized with an array of arrays, and it's an array of array because each array in that array is one key value pair. So here you could have key and then some value. And the key can be of any kind, doesn't have to be a string, can be a number, can be another object, and values can also be of any kind. So here, for example, we could initialize this map with one entry, so with one nested array here, where the key could be person 1. So the object itself, the address of that object, but therefore it is the object itself which is used as a key here. And the value could now be the additional information which you want to store for that person, which you don't want to merge into that person. So let's say another array here, which holds information about purchases this person made. So it might be an array of objects even, where you have a date. Yesterday might not be the most usable date, but it'll do here. And then price 10. So quite a lot of nesting going on here. We have one array overall with a nested array in there, which is one key value pair we want to add to this map, where we have a key and where the value is then simply another array here. Doesn't have to be an array. As I mentioned, you could have anything as a value here. An array, an object, a number, whatever you want. Now if you create it like this and we then console log person data here to have a look at it, let's see what we get. Let's save that and let's reload. And you see we get a map here, which looks a bit strange, but if we drill down, we in the end find this entry here, where we see we have our object as a key, and an array as a value. And if we expand it, we see the key is this object, and the value here is in the end an array with one object, which in turn has a date key and this price. So this is what I created. Now, the idea again is that you can have any key, and for example, the advantage here is that we can use an object as a key and attach extra information to it. Now, this extra information is not merged into the object or anything like that. It's stored in the map instead, but we can use that map in the part of the application where we need that extra information and have that tight connection to this object. And since we use that exact same address, we can also easily extract data from that map, as I can show you here, by simply using person data, so my map here, and then here you can call get to get a value by key and just enter this object. And it's the same object since I add this object, so the exact same address here as a key, which I use here to retrieve it. This behind the scenes uses a equality comparison and works because it is the exact same object, not a copy or anything like that, the same pointer at the same object. So this can save you the hassle of having to, for example, add an ID to every object so that you can use the ID, which might be a string, in a regular object as a key, and then extract the value by the ID of another object from that yet another object where you store the extra information. With a map, where you store the extra information, the object itself can be the key, and therefore you don't have to add any IDs or extract that or create arbitrary string keys. Instead, you can use the object as a key and retrieve values by just using that object as a key. And hence, if you save that and you reload here, you indeed get this object output there. So this works just fine. So this is, by the way, how you get data from a map. Of course, you can also add data to a map after it has been created. And you do this with the set method. There you set a key value pair. So the first argument here has to be a key, which again can be of any value. You can also have mixed key types in the same map. So you can have a map where one key is an object and another key is a string. But here I'll actually use person2 as a key. And then the value for that person, well, in my case here, it'll again be an array where you might have your purchase objects in there, date 2 weeks ago, price 100, just like that. So that's just a dummy example here, of course, but now we also got that other person stored in that map, and hence if I reload and we have a look at this map here, we see we got 2 entries in there with our 2 different objects as keys. So a map is really versatile regarding the keys, and it can therefore be great for use cases like this. Now you can also output all information in a map in 3 different ways, always using a for loop. So for one, we can loop through all the entries with for const of entry, or any name of your choice of course, where you then access person data.entries, which is a method. You might remember that from the set. There we also had this entries method, which returned this strange array with the same value twice. Well, let's see what this yields us here. So if I console log my entry here, when we go through all entries, and we save that, and then reload, this is what gets logged here, these 2 entries. Now what you see here makes more sense than for the set. We log an array essentially with always exactly 2 elements, where the first element is the key and the second element is the value. So for a map, it makes sense that this is an array of exactly 2 elements, because we can then have key and value combined in one, well, value in one array here. And for the set, as I mentioned, they just did the same so that you could easily reuse code, I guess. Now, therefore, since you also learned about array destructuring, you could of course also rewrite this as key value and pull out the key and the value, these names are totally up to you, out of this array, which is guaranteed to have exactly 2 elements, the key and the value, and store them in constants, which are available inside of that for loop, of that name. So then we can output key and value like this, for example, using this array destructuring syntax you learned about. Since we get an array with exactly 2 elements, we can use this syntax to pull out these elements and assign them by their order to these variables or to these constants, which we can use in here. So if we save that and reload, you see this output, key, value, key, value. So that also works. So that's one way of going through all entries. Another way is to again use a loop here, but maybe you're just interested in the keys, let's say. Well, then you can go through all the keys by using person data, or whatever your map name is, keys. Keys is also a function which you execute, and as the name suggests, this gives you access to all the keys and nothing more. So if you only need the keys and you're not interested in the values, of course you could also use this approach and just not do anything with the value, but this is then a bit cheaper and shorter. It just goes through all the keys and, unsurprisingly, logs them here at the bottom, this here from line 26. Well, and you have the same for values. So if I duplicate this, we can also go through persondata.values, maybe name this value therefore. Of course, as always, this name is totally up to you though. And now we only go through the values. So whenever you just need the value, well, that's also possible with this approach. Well, and then you have a couple of other nice methods on a map here. They should be pretty self-explanatory. The clear method clears all data from a map. The delete method deletes a single entry by key from the map. For each allows you to go through all items, which is an alternative to the for off loop. Has allows you to check whether a certain key is part of the map. Set allows you to set a value, while in size tells you how many items are in the map at the moment. This is not a method, but just a property which you access, which you can output like this. So if we do that here and reload, here at the bottom we see 2, because we have 2 key value pairs in the map. So that is maps. So as you can tell, maps in a way are pretty similar to objects, which of course raises the question, when should you use which? So let's compare the two. Maps can use any values and any types as keys. So you can have an object as a key, a string, a number, and in the same map you can have mixed key types. Objects, on the other hand, can have mixed key types, but you are restricted to using strings, numbers, or symbols. We'll learn about symbols later. So you have less flexibility there. You can't use a boolean as a key in an object. You can't use another object or an array. For large quantities of data, and with that I mean more than 10 entries, really large quantities, maps can provide better performance than objects do. So that might be one possible use case if you're working with large amounts of key value data which you need in your application. And in many applications you might never really have that much data. But if you do have that, that might be a place where you want to use maps. Whereas objects are perfect for small or medium-sized sets of data. And with that, I really mean medium-sized, not in the sense of 5 key value pairs, but still pretty big. 30, 40 key value pairs, that's certainly not a problem for an object. Objects, by the way, will also have another advantage, which we'll see once we dive deeper into objects in the Objects Deep Dive module. You can have methods that interact with the data in the object. That's not really possible on maps. So if you have methods that need to do something with the data that's part of the object, that's a strong reason to use an object. Now, maps also can yield better performance when adding and removing data frequently. So if you have some operation which adds key value pairs and removes key value pairs multiple times per second, then a map might be worth a look. Objects, on the other hand, in general, are easier and quicker to create, not just because you have that shorter syntax with curly braces, but also from a performance perspective. New map takes a bit longer than creating an object with curly braces. Though, as always, with all these performance things, it's always important to keep in mind that we're talking about differences which you won't feel in the majority of apps you're building. So in general, the summary I want to give you here, not just about maps versus objects, but about arrays, sets, and maps and objects in general, is that in probably around 98% of cases, you will work with arrays and objects. Sets and maps have their niche cases where they can shine for a unique value, which has to be unique in the case of sets, for large quantities of fast changing data in the case of maps, or if you have some use case where you have some data, let's say an object, where you kind of want to attach extra data which you don't want to merge into the object, as we did it in this example I showed you in this module, then you could also think about using a map to use the object as a key and add the extra data as part of the map instead of as part of the object. But again, in the vast majority of cases, you can focus on arrays and objects, but since sets and maps exist and you might encounter them in other code, and you might personally also end up in some application at some point of time where you can benefit from them, it's of course important to be aware of them and to know them. Well, and with that, there actually also are two specific versions of sets and maps, which are also quite interesting. I'm not entirely done with sets and maps yet, because there are specialized versions of them. Let me comment this out, and let me introduce you to weak set and weak map. Now, what is that? Let's say we have a person here. It's not a constant, but a variable, name Max. And I want to store this in a set. Now, previously we had a set of strings, but of course you can store any data in there. You can store objects in there as well. Now, in the case of the weak set, which I'll show you, it has to be object data to be precise. So here, persons now is my new weak set, which now requires objects to be stored in it. That means you can also store arrays in there, since they are objects in the end, but you can't store numbers or strings in there. So here, I'll actually initialize this to be an empty set, and now I can add a new entry with the add method and add person. Now, right away, when you type persons dot, you see there are way less methods available. Only add, delete, and has. There is no method to get all the entries, for example. And the reason for that is that weak set, just like weak map, which I will also show you, internally works such that it can only store objects, so that it can actually clear these objects for you, release them to garbage collection, which I covered in the behind the scenes module, if you don't work with a certain piece of data anymore. Conveniently, if we console log persons here, the browser DevTools console still allows me to look inside of that. If we reload here, we can actually have a look into our set and see the value here. Now you might wonder, why would I need this strange thing? Well, if you have an application where you store data, let's say in a set, object data in a set or other arrays, where you eventually will let go of data, then you want to make sure that this data can be garbage collected. Now, if we work with that person here, let's say, and then we do some operations with it, and we needed it in the set for these operations, and we still need the set thereafter, maybe for other operations, but this person is not really required anymore, then we can set person equal to null. This means we set this variable to null, so this object no longer has anyone who's interested in it. This person variable, which stored its address, is now reset to null, so the address is released from there, and the JavaScript engine then is able to pick this up and eventually clear this object from the heap. That's what garbage collection does. It clears that data from memory. Now, if you would use a normal set here, which you can normally, then the person you created here would still be part of that set. So even if you cleared your variable here, you added that object, that pointer at this object, to the set. And JavaScript, thankfully, detects that and will not clear the object, because the set still holds a reference to it. And that's good, because JavaScript would expect that you plan on working with that, and deleting it therefore would be bad. Now let's say you eventually never end up working with that person again. Then with a normal set, you have that unnecessary data stored in memory because you have that data in a set even though you don't need it anymore. Sure, you could have done persons delete and deleted that value, but if you forgot that, well, there you go. Now with weak set, if you reset all other places where you point at this object, the weak set will not hold on to it. So the weak set allows garbage collection to delete items that are part of the set as long as no other part of your code uses these items. So now with that, eventually, that will be garbage collected. Here, if I reload, we can still see that person. So it certainly didn't get garbage collected between this line and this line, but garbage collection can't be planned. You don't know when the browser does it. The thing is, with this here and weak set being used, it's able to garbage collect this. So weak set is an interesting option in cases where you store object data in a set and you eventually release some of that data, and you want to make sure that this then can be garbage collected. Obviously, super advanced, not something you'll use in many applications, not something we need here in the majority of this course, to be honest, but something to be aware of, especially as you grow as a developer and you will encounter more and more advanced programs, advanced code snippets where something like that might get used. Now, with weak map, we have a similar idea as with weak set. So I have my person here. Let's say I didn't reset it yet. And instead now I also want to have my additional person data here. So person data, again, can be a map. But then if we use that person here as a key, we have the same as with the set, with the normal set. If we clear person, if the map is a normal map and we have person as a key there, the map will hold onto it and not release it for garbage collection. Might be what you want, but if you know you don't need that, you could use a weak map instead. Now, on a weak map, you can, of course, also call a couple of methods, way less than before, because again, you can't loop through the entries, because the entries, the amount of entries and so on, is simply not guaranteed, which is why the size property is also not available. JavaScript can't really tell what's in the map because it can look at it if you ask it with has and get if something is in there, but other than that it doesn't know if something has been released yet, which is why you have that stripped down choice of methods. But what you do have, of course, is set, and then we can set person as a key, and now here keys have to be objects so that this garbage collection thing makes sense, and any value. The value does not have to be an object. That could just be a string or whatever you want here. Now with that same logic as before, as soon as we let go of that person object in all other places, like here where I set my variable to null and therefore I get rid of the address which was stored in there, JavaScript is able to garbage collect this, and the weak map won't stop it from garbage collecting this here, so from garbage collecting this person. And therefore here still we will probably see the person if we log this weak map, but eventually that will be garbage collected and it will not be part of that weak map anymore. So weak map and weak set, advanced, very advanced concepts which you will rarely use, but which can help you manage memory more efficient in large applications where you have data which is fine to be deleted at some point, which you might want to manage in a map or a set and where you don't want to take care about manually clearing data. Well, then weak map and weak set are great. As I mentioned, not really something we'll immediately use here, not really something you'll need in a lot of applications, to be very honest, but something you should at least have heard of if you want to become a JavaScript developer, so that it is something you can utilize in bigger applications, more advanced applications, and in your future career as a JavaScript developer in general. So we're done with this module. Was a large module with a lot of content about arrays, different ways of creating and accessing arrays, different ways of manipulating arrays, all these amazing array methods which help you transform arrays, sort them, add data, remove data, splice, which was a really convenient method to manipulate an array. You also learned about the spread operator and array destructuring, and we had a look at sets and maps, which arguably are niche features which you don't need every day, but which every JavaScript developer should know. And you might encounter situations and applications where you can actually improve your code, improve your performance, improve your memory usage by using set, map, or weak set and weak map even to improve your application. So overall, a lot of key concepts covered here. Of course, the array things, the array methods we had a look at, and so on. These are the most important things we worked with. And these are the things we'll, of course, also, as always, encounter throughout many modules in this course, and which you will encounter throughout your entire career as a JavaScript developer, because arrays are just such a crucial data structure, and being able to work with them, to manipulate them and so on, is super important therefore.